Okay, so this section, you might have noticed we skipped 7.6. We also skipped 7.4, but that's okay. We're going to talk about a multiplicative inverse for a matrix and how we use those to solve a system of equations. Well, to start out the chapter, they start with this problem, and I want to talk a little bit about how you set up a problem like this. So it says Nancy plans to invest $10,500 in 2 different bonds to spread out her risk. The first bond has an annual return of 10%. Second bond has an annual return of 6%. In order to receive an 8.5% return from the 2 bonds, how much should Nancy invest in each bond? Well, what you're looking for is how much are you going to invest in the first bond? I'll call that X. And how much you're going to invest in the second bond? I'll call that Y. Now, to set up the system, we know that X plus Y has to equal 10,500. Okay? All right. Now, the next part talks about the investment. How much money does she make on her first bond? Well, 10%. So we're saying 0.10x. That's how much she's going to make from that account. And then, and this is in a year, 6% annual return. So on the second bond, so 0.06y has to equal. Now, here's where it's a little bit tricky in this problem. That's how you figure the interest for the year on the 2 accounts, but it says she wants to receive an 8.5% return from the 2 bonds. Well, what's that 8.5% of? The 10,500. So we need to take 10,500 times 0.085. So let me do that really quickly on a calculator. And I get $892.50. Now, we're not actually going to figure this problem, but I wanted to show you how to set it up, the system of equations, because you might have a problem similar in the homework. Okay, so that's how you set that up. And now you have a system of equations with 2 variables. Okay, now we're going to talk about how to solve that system. Well, there's different methods. We have used a system, we have solved systems of equations with 2 variables, like that problem, using substitution or elimination. But there's another method, there's other methods as well, but the method we're going to talk about is using an inverse, okay? So first let's talk about what a multiplicative inverse is. So if you have 2, and you multiply it times the multiplicative inverse, it has to equal 1. So that's 1/2, right? Okay. So 2 times 1/2 is 1. So these 2 are multiplicative inverses. Okay. Now you might remember, you'll probably remember, we've had equations in the past where you had 2x equals 14, and you said, oh, I got to solve it. I'll divide by 2, and I get x equals 7. So that's probably old hat now. But maybe you had a problem like 3/4 x equals 15. And you said, oh, I've got fractions. I don't want to divide by 3/4, so I'll multiply by the reciprocal, 4/3. And why did you do that? Well, because this makes 1, right? Those are multiplicative inverses. So you get 1x equals, and then you have to do the math over here. So what do you get, like 20? And then 1 times x, that's just x, right? Because 1 is the multiplicative identity. Okay, so this is all really important stuff when we go to use this in matrices. And then so you're able to say x equals 20. Okay. So when we have like a matrix equation, when we're dealing with matrices, you can't just do the division. There's no division in matrix work, okay? So we have to multiply by the inverse. Oh, I want to talk about the notation. Okay, so when we have A and we multiply by the inverse, that equals 1. So that's what we were doing over here. We were saying, okay, 3/4, and then we're going to do the inverse of that, which, in multiplication with real numbers, you can think about the reciprocal. But remember, we're not going to be doing that because we're going to be using matrices. Okay, so we have to find the inverse is what we're going to have to do. But that has to happen for real numbers. It also has to work the other way. That if you take the 2 and you multiply them, it's going to equal 1. That is in multiplication for real numbers, okay? Now, and that's hopefully all fine and good. You've seen that notation before with the -1 up there, meaning inverse. If you remember when we did functions, we said, well, we have a function x, and then we have the inverse function of x. Remember, we had that notation. Okay, so now we're going to talk about, back to multiplicative inverses. So for matrices, I'll have a matrix, call it A, and then its inverse will be A to a subscript of superscript of -1. Okay? All right. Okay, so that's multiplicative inverses. Now we're going to talk about identities. How do you get an identity in matrix multiplication? Well, here's how it works. So if I have a little matrix, A, B, C, D, and I'm just going to tell you what the identity looks like. It looks like 1, 0, 0, 1. Because what happens is when I multiply the first row times the first column, I get A times 1 plus B times 0. Okay? And then I do the first row times the second column, I get A times 0 plus B times 1. And then if I do underneath the second row, first column, that's going to be C times 1 plus D times 0. And then if I do second row, second column, I get C times 0 plus D times 1. Well, what happens when you simplify all those little elements? Well, here you're going to get A. Here you're going to get just the B because A times 0, right? So you're just going to get B. Here you're going to get just that C. And here you're going to get that D. So you see how it makes it the same matrix that you started with? So that's why it's called the identity matrix. So how do you find an identity matrix? Well, for a 2 by 2, there it is. Now, we say that's the identity matrix sub 2, meaning it's square, okay? So it has to be a square matrix to be an identity matrix, and you can put that subscript for the dimension. So it's two rows, 2 columns. Okay, so what does a 3-row, 3-column look like? So what does the identity for a 3 by 3 look like? Well, it's going to be 1s down the diagonal and 0 every place else. Okay, so it looks like that. And then if you wanted I4, which we're not going to have that big of a matrix, but if we did, I mean, they're out there, it'd be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. Okay, so it'd be 4 by 4, and you'd have 1s on the diagonal and 0 every place else. Okay.